Hello, I'm Fatbarda Lamcha. Together we will have some lectures in the course Advanced Technologies in Agri-Food Processing. These lectures are mainly focused to the application of classical and advanced technologies in food processing, with the purpose of having products with high quality and high nutritional value, and especially products that can provide safety for human health. The aim of these lectures is to provide technological knowledge and practices for the production and preservation of a wide range of food products. The topic of today is basic food microbiology and talks about the characteristics of food microorganisms and their impact on food products and human health. We know that the microorganisms are present everywhere, and the food might not make an exception. They are commonly found in raw materials, and normally they will get introduced into many food processing. Microorganisms in food are different. Not all of them have the same effect on the food. Some microorganisms are beneficial because they cause desirable changes in food, such as the fermentation process, like in wine, for example. Some other microorganisms can cause undesirable changes in foods. They can spoil the food, and such product often become unacceptable for human consumption. Some other microorganisms pose a risk to human health. Eating foods contaminated with these microorganisms can cause food poisoning. The science who understand and who explain all these three different types of microorganisms is called food microbiology. Food microbiology is an old science who studies microorganisms that inhabit, create or contaminate food. The development of food microbiology began with several studies of thermally treated foods, and it was observed that after the treatment of these products, the development of microorganisms was totally inhibited, and the foods could be stored for a longer time without being spoiled. The science of food microbiology is an emerging science. Special attention is given to food pathogens that present a major public health challenge. They are not only the source of food spoilage, but they have often been the leading cause of food epidemics. The science of food microbiology has allowed us to better understand food microorganisms, thereby defining the right parameters for processing, but also determining their storage conditions, providing sustainable but especially healthy foods for the consumers. Food spoilage agents are mainly bacteria, yeast, and molds. There are several factors, both in food products and in the environment, that influence the growth or survival or the development of these pathogenic microorganisms in food. In this lecture, we will discuss various topics such as factors, especially factors that influence the growth and survival of microorganisms in food, various foodborne spoilage and pathogenic microorganisms, and especially their impact on human health. Food processing help for controlling these microorganisms in food, etc. These are some of the topics that we're gonna discuss and explain in this lesson. Well, microorganisms in food derive from various sources, such as fruit, vegetables, animals, birds, air, soil, additives such as spices or even other additives. Various factors affect the growth and survival and the development of microorganisms in food. These factors are classified in three classes: intrinsic factors, such as the properties of the food or just the microorganisms itself, and extrinsic factors. Here are those factors that are related more with the environment, and the third class is other factors. Let's see each of these classes. Intrinsic factors. Well, as you can see from the screen, there are lots of factors that affect the growth and development and even the survival of microorganisms in food. Each factor is because of the properties of the food. Let's see more closely each of one. Acidity, pH, and buffering capacity. The reason that for many years people have used fermentation process for conserving food products. These because of the ability of the acids to inhibit the growth of pathogenic microorganisms. Because we know that most of bacteria are not tolerant of high acidity. Weak organic acids have a better antimicrobial action than inorganic acids, and therefore these acids are more commonly used in foods and produced during the food fermentation. Some of the weak organic acids that we might mention are acetic acids, lactic acids, citric and malic acids. pH value of the food product. pH is a function of the concentration of hydrogen ions in foods. Because of the pH value, the foods are divided into two big groups. Foods with a pH value below 4.6, and these foods are called high acid foods, and the other group is those that the pH value is above 4.6, and these foods are called low acid foods. Why is set this limit of the pH value? Because the limit 4.6 is set because this value, in this value, one of the most dangerous foodborne pathogen, Clostridium botulinum, cannot sporulate, and especially it cannot produce toxins on foods. The optimum pH value for the growth of microorganisms is usually close to neutral, pH 7. Although the most of bacteria do not grow on the value of pH below the value 4.6. The pH value of food products is important because it allows you to determine the right food processing techniques for a better conservation and especially having a safe product. Buffering capacity. Buffering capacity of a food refers to its ability to resist any change of the value of the pH. Therefore, this ability should be taken into account when we want to acidify a food with different acids or fermenting a particular food for storage. Usually, fruits and vegetables have a lower buffering capacity compared to foods with a high content of proteins. Apples, orange, strawberries, fruits in general undergo more spoilage from mold and yeast rather than bacteria, because yeast and molds can grow to the pH below 3.5 or 3.6. Alkalinity at a pH 11 or more higher is also detrimental to bacterial growth. But such a high value of the pH would give a very basic food for the consumers, with a very bad taste, very bad aroma, and certainly a non-consuming fruit product for the consumers. Because we have to know that we might change, we might work with acidity or pH value of the food, but we can alter this level of the value of these factors in a product, but we can work with them to that level that those foods might be consumable for the human being without changing its quality. And the same is even for the acidity, just for the pH and for the acidity. Water activity. Well, water activity has always been controlled by the producers through the different processes, like drying process of the food, like adding some additives like salt or sugar, through freezing process. So in this case, foods become more resistant to microbial infection, and especially to the chemical deterioration. The most important purpose is to make a sustainable and safe product, healthy and not danger of the health of the consumers with their microorganisms, toxic microorganisms that might develop in food, or especially their toxins. The advantage of nowadays is because it is recognized the importance of water activity and its impact on microbial growth. Water activity is one of the most important intrinsic factors because this factors is a good indicator to predict which microorganisms might survive in a food product. Microorganisms have a limited level of water activity, below of which pathogenic microorganisms will not grow. We emphasize that we're talking, I want to emphasize that I'm talking about water activity rather than water content, which determines the lowest limit of water available for microbial growth. The lowest value of water activity in which most food spoilage bacteria grow is about 0.9, 0.91, and for this value of water activity for the growth of molds and yeast is about 0.61, 62. From all the above, it's easy to understand how water activity is useful in predicting food safety and its stability in relation to microbial growth, or even the chemical and biochemical reactions occurring in foods and physical properties. By controlling the water activity of food products, it is possible to predict which microorganism will be a potential source of decay and infection. By controlling the water activity of food products, it is possible to maintain the chemical viability of foods. It's possible to minimize the non-enzymatic reactions, etc. Another factor that is an important factor also is redox potential. Redox potential is the measurement of the ability under specific chemical conditions of species to lose or gain electrons. When electrons are transferred between two compounds, there's a potential difference created between them. And exactly this difference can be measured by an instrument and expressed in millivolts. This value represents the redox potential. To simplify the redox term, we can say that it expresses the concentration of removable electrons, which can remove from one molecule to another, while the pH value expresses the concentration of the protons. So redox potential represents how easily the electrons can be transferred into the solution. Highly oxidized products will have a positive redox potential value, and highly reduced products will have a negative redox potential value. Each species has its own redox potential. For example, the more positive is this value of redox potential, the greater is the affinity of the species for electrons and tendency to be reduced. The growth of microorganisms at certain redox potential values can also be influenced by other food components, such as the presence of the salts, processing treatments that the food might undergo, etc. Presence of nutrients. Well, nutrients in food products are very important because they can affect the growth and development and survival of microorganisms in them, especially survival, because different microorganisms, have different needs for nutrients, such as carbohydrates, proteins, fat, vitamins, minerals, for their growth and development. For example, let's say Salmonella enteritidis needs for iron to grow well. As sources of the energy, microorganisms may use carbohydrates, alcohol, amino acids, and fats. Amino acids and proteins are the main source of nitrogen for microorganisms. Some of the minerals needed for microbial growth include phosphorus, calcium, iron, sulfur, manganese. These values in small quantities that we might find in every food. So for the minerals, microorganisms could find them everywhere in all the foods. These elements are in small values, usually are. So, depending on the nutritional content of the food, might be defined the type of microorganism that can be developed in that food. For example, plant-based foods are generally rich in carbohydrates, some proteins, vitamins, and minerals, while animal-based foods are more rich in protein, in lipids, and less in vitamins or minerals. So, in this way, we can determine which microbe or pathogenic microorganisms needs carbohydrates and which one needs proteins. Another factor is biological structure of food. Well, many food products have a natural protective structure against the threat of microorganisms. When we talk about microorganisms, usually we talk about pathogenic microorganisms because they will destroy the food and they will affect negatively in human health. Well, these layers, these protective layers, may be protective covering on foods, such as some examples is egg shells, poultry skins, fruit or vegetable skin, or the fat layer on the meat that may protect a part of the meat, etc. These outer barriers usually are made from macromolecules and provide an inhospitable environment for microbes, such as the presence of short-chain fatty acids on animal skin and essential oils on plant surfaces. As long as the outer cover is intact, internal contamination will be prevented. However, these external barriers can be damaged during the transportation, during the handling, the processing, the storage, allowing the entry of microbial or pathogenic microorganisms and subsequent growth under appropriate conditions into that food. For example, some cracks in eggshell microorganisms can enter and grow under favorable conditions on that food, on eggs. The maturity of plant foods can affect the effectiveness of these protective barriers. For example, the skin of very ripe fruit is softer and more prone to damage than non-ripe fruit. It has a firmer skin and pulp. Antimicrobial factors. These antimicrobials might be natural or synthetic. Well, traditional food preservation methods are less efficient in reducing the growth of pathogenic food products. So, in recent years has been an increase of the consumer's demand for foods without chemical or chemical-free. But their preservation, food preservation, is very difficult because it requires the application of these antimicrobials to have a safe food. The use of these antimicrobials is a new technology being applied in the food industry to increase the shelf life of food and overcome the issue of food quality and safety. These substances, antimicrobial substances, might be natural or synthetic one. But natural antimicrobials are gaining more and more importance than synthetic ones. An example of antimicrobial is the use of oregano essential oils combined with the modified packaging atmosphere, which promotes the increased shelf life of the meat, especially chicken and beef meat.